All right, next we're going to talk about integrals for bases other than base e. So here, the integral of a to the u du equals 1 over the natural log of a times a to the u plus c. And you might also see this as a to the u over the natural log of a. And again, we can think about our integral of a to the u du as being the derivative of what function equals a to the u. Okay, and so we know that the derivative of a to the u equals natural log of a times a to the u. So how can I alter this so that it equals just a to the u? Well, you can see here that I would just divide by the natural log of a, and then I would be left with a to the u, which is what we're looking for. So that's why what goes in the middle here is a to the u over natural log of a. Okay, at any rate, let's go ahead and try some of these examples. So here we have the integral of 2 to the x dx. We still want to find a, our base is 2, and we need to find our u, which is our exponent, which is just x. And now our du equals 1 dx. So it's important when you're integrating that we remember that dx there. So do I see a to the u du? Well, let's see. So 2 to the x, well, that is a to the u, and then dx is du. And so I do see this function, meaning this is going to equal a to the u over natural log of a. Okay, and we can substitute back in now. So this is going to be 2 to the x over the natural log of 2. And don't forget our plus c, because this is an indefinite integral. All right, let's move on. All right, for letter b, we have the integral of 4 to the negative x dx. So again, a is going to be our base, which is 4, and u is going to be negative x, and so du in this case becomes negative 1 dx. And you can see here we have dx, but we don't have a negative, so that tells me I'm going to put a negative outside the integral and a negative inside the integral. And now I have a to the u du. So our final answer here is 4 to the negative x, so a to the u, over the natural log of a, which is the natural log of 4, and then don't forget that negative that was out in front needs to continue there with us. So this is the negative of 4 to the negative x over the natural log of 4. All right, let's take a look at letter C. Here I see x times 6 to the negative x squared, and we might think product rule right away, but let's check our a, u, and du first. So here a equals 6, u would equal negative x squared, and du equals negative 2x dx. Okay, so I see an x and a dx. All I'm missing is that negative 2. So we're going to rewrite this here as the integral of negative 2 times x times 6 to the negative x squared dx. And since I put that negative 2 inside, I'm going to have to put a negative 1/2 on the outside to balance it. So now if I used u substitution, I would have negative 1/2 times the integral of 6 to the u du. And if I integrate this, I'm going to get negative 1/2 times a to the u over the natural log of a. Okay, and if we just rewrote this, back substituting our c, we get negative 6 to the negative x squared over 2 natural log of 6. Okay, so that is integrals for bases other than e. Let's move on. We have one other topic. I want to show you 4 forms of exponential differentiation. So we're going to go back to differentiation for a second, and we're going to look at 4 different forms that you might see e involved in. And we want to find the derivative or y prime for each equation. So in this case, here we have y equals e to the e power. Okay. Well, e is a constant, and e is a constant, so a constant to the power of a constant is a constant. So this is really just an application of our constant rule. Okay, so the derivative of a constant is 0. In this case, we have y equals e to the x, and so now we have an exponent that isn't a constant, so now we're going to use the exponential rule. Okay, so when e is your base, that's a constant raised to x, which is a variable. So here, y prime is just going to be e to the x. In letter C, now I have x to the power of e. And remember, e is a constant, so this is really just the power rule. So here, y prime is going to equal e times, because we're going to bring e out in front, x to the e minus 1. Okay, so those are 3 of the forms. And let's move on and talk about the 4th. Now the 4th one is going to involve some powers that can look a little bit crazy. And for these, we're going to use logarithmic differentiation. So this is the 4th form and probably the most difficult. So here you can see we have a variable raised to the power of a variable. So we're going to have to use logarithmic differentiation here. So again, we follow our steps. We take the natural log of both sides. Okay, so first, let's go ahead and expand this natural log right here. So we get the natural log of y equals x times the natural log of x. And let's go ahead and differentiate both sides. So the derivative of natural log of y is just y prime over y. And then in the right side, we're going to have to do the product rule here. So the first function times the derivative of the second, which is just 1 over x, okay, plus the second function times the derivative of the first, which is just 1. Okay, and let's simplify this now. So we have y prime over y equals x times 1 over x, which is 1, and then plus ln of x. And we want to get y prime by itself, so we're going to multiply both sides of the equation by y. So y prime equals, and let's substitute y back in here. So we have x to the power of x times 1 plus the natural log of x. Alright, so that is using logarithmic differentiation when all of your powers and bases are variables. Alright, let's take a look at letter E. Again, we have a base that is a variable and a power that includes a variable as well. So this tells us to use logarithmic differentiation. So let's take the natural log of both sides. Okay, and we'll expand this one right here. So the natural log of y equals 2 times the natural log of x over x. And now we want to take the derivative of both sides. Okay, so we have y prime over y equals, and now we have to use the quotient rule. So it's the low function times the derivative of the high, which is going to be 2 times 1 over x. The high function times the derivative of the low, which is just 1, all over low squared. So all divided by x squared. Okay, and let's simplify this a bit here. So we have y prime over y equals, well, x times 2 times 1 over x is just going to be 2 minus 2 ln x over x squared. Okay, so that's pretty good for now. Next step is to multiply both sides by y and substitute in for y. So y prime equals, let's see, y is x to the 2 over x. And this is going to be times 2 minus 2 natural log of x over x squared. Okay, and then to finish simplifying this, we're going to factor out a 2. And that would leave us with a 1 plus ln x. And then we're also going to do x to the 2 over x divided by x squared. And so we're actually going to subtract these right here. So it'll be times x to the 2 over x minus 2. Okay, so either of these forms would be okay with me, but you might see it in the book written like this. Alright, so those were the 4 forms of exponential differentiation, and we also covered the integrals for bases other than e.